Hola community, welcome to the first video from the Blender Studio in 2021. This one is for fields. What is fields? Why are fields?
Geometry nodes fields.
Yes.
This is something entirely new that's come to Blender 3.0 that took the first ideas we had for geometry nodes and changed it upside down and made it more complex, a bit more flexible, a bit more complicated in some ways, but hopefully overall it works better and it's easier for people to learn how to use. And that's what we're here for.
That's what we're here for. So you wrote a blog post some last month actually.
Last month, Jacques was here, Jacques Lucke, and he was working with Hans Goody on a prototype for this concept of fields. Before we had what we're calling a pure data flow centric approach, which you have the geometry and every node will just operate into the geometry. And then with the fields, the idea is that some nodes can operate into the geometry, let's call them geometry nodes, while other nodes are just passing along functions to be then processed and evaluated in those other nodes. And this changes a lot. This changes how we read old files, so we expect people to have to adapt to the new system.
Yes. And that's what we're gonna do today.
Yeah.
Okay, so let's see. I downloaded the latest Blender, right? If I just download it from the buildbot and I have it already, and I'm gonna download a file from Simon Thomas that it's also available for download in the geometry nodes page. It's one of the test files for the first iteration, right? For the scattering.
And this was the first test file we officially published. So that's why it's a nice example. It's simple to the point.
Yes. So first thing, okay, I know nothing about this. I see that it's actually working in a way. There's some scattering happening, but in the node editor, I see a bunch of warnings.
Not only the node editor, if you go to the modifier, you should see there as well.
Node tree legacy.
Node has legacy node.
Okay.
If you mouse over the warning, it should also tell you when you should start getting concerned about it. So basically, the legacy nodes will be removed at some point before Blender 4 in 2 years from now.
Okay, so before 2 years, this will be gone. How do I know which ones are legacy? Is there a list, or I can, or it's just gonna show the warning?
Basically, every one of the old ones, so the legacy ones, they're gonna show the warning. And if you try to add a new node, it's simply going to only gives you the option to add the new nodes, the non-legacy ones.
Okay, so I can see the attribute list is pretty much empty compared to what it used to be.
That's the a good question, Pablo. That's the big change we have when it comes to pipeline, to workflow. With the old system, you'd have every node referring to an attribute in the node itself. So in this example, you can see the scale is an attribute there. The pebbles large in the point distributor is an attribute. And with the field system, and back then we needed then specific attribute nodes to operate on those. So in this case, you're using the attribute random node to populate an attribute with some random values.
So in this case, I'm taking the vertex group pebbles large or L, and then randomizing the scale and the rotation. How can I do this in the new system? How can I convert this? It's not automatic, right?
It's not automatic yet.
Okay.
When you say that we might remove those before 4.0, is that if at some point someone from the community can help us with a backward compatibility, some do versioning code, we can even remove them automatically. Right now, we have to do it manually, though.
Okay, so teach me how to do it. First step.
First up, so the first thing you need to be able to do is to have the attribute you want to use as a mask. So in this case, the pebble large exposed outside the modifier.
Okay.
So the easiest way to do it, I would say, start adding the new distribute points interface. So the new point distribute node.
Okay, so this is a point distribute. I just need to replace it with the new one. So I can just search for distribute, and it's called distribute points on faces. It even changed the name.
Yeah, we took this as an opportunity to make the name a bit more accurate. And as you can see, the parameters change a little bit as well. This you're looking to the random option. If you go back to the pause on disk mode, even that you can see, now we have the selection as a new option. And most of the nodes, almost all of the selection node, all of the geometry nodes will be able to support selection into the future. Because any operation that you're doing that to the geometry can easily be done in a subset of the geometry.
Wow.
So it's something.
So you can limit it, and this is like a. Why does it look different? What is with all these shapes?
So many questions. Let's start with the shape one. Simple. We have 3 shapes that you see there. You see they have the circle one, which represent data. A data is something that can be inspected. So for instance, if you connect the input geometry into that node, and then you mouse over the points, we get exactly. Oh, you need to connect this to the.
Makes sense. To the end. Let's see, to the end.
Yeah. I'll just connect instead. If you inspect the points, it's gonna tell you exactly what is there. The data that's being passed along the noodle. Same things for normals and rotation. Oh, you're not using it, so it's not being computed yet.
For performance, I guess.
For performance.
Yeah.
It's also the same data. You can inspect in the spreadsheet editor. If you connect this geometry to the
viewer.
To the viewer node.
So
I don't have to do it.
I want to see it. Okay. I see there is 432. That is correct. Okay. Now what?
Now the other shape you have is a triangle. Those are fields. Maybe it's easier to explain than
by connecting it to something.
By connecting it to something.
Okay, so what can I do? First, I have the distribute points, and then I need to instance this. I guess I need to instance the.
I could, for instance, the easiest way to see fields maybe later in this example. I think we're gonna have a few fields which really work with the new system.
Yeah.
But fields basically, if you connect the normal to the rotation to a node to the math node.
To a math. Vector math.
Vector math.
Okay, so I can connect this. What?
Yep. And then you connect this vector to the.
A...
Usually, I'll put. Maybe it'd be easier if you just put the instance on points already.
Yeah, I can see that. Okay, and then I connect to the rotation and I pass on the points.
Yeah. Do we get to see the viewport there? Yes, we're looking at it.
Yes, send the viewport.
Now we're not instancing anything yet. That's the other new thing about this node. So before we have the point instance node that you could pick whether you want to instance an object, a collection, or
these are the two.
Or geometry.
Is comparing the old one. So you could only choose collection, geometry, or object.
Yeah. Geometry is not even new for people that were on 2.93.
Oh yeah, that is in 3.0.
Which is fantastic. So you can basically instance any geometry. So for instance, create a cube node. Geometry primitives cube. And then connect the geometry to the instance.
Oh, just like that.
Yep. And you should be able to see then. Maybe scale them down a little bit. I was going even to scale the instance, but that's good.
To scale the instance. No, I'm a pro already in this.
But now the rotation, for instance, you can try to
change
it. You can just add. Something's gonna happen. Yeah.
Yeah, it's adding to the X, right? To the X rotation or Z rotation.
And in this case, you can just think, okay, just the normals are being passed through. But first, if you try to mouse over the diamond socket, it doesn't really evaluate yet, so it still doesn't know what's its value. It's only gonna know the value when it gets all the way to the node that's using it.
To the rotation.
But basically, it says it's depending on something else. It's depending on the normal
so
field.
Interesting.
Yeah. This name might change. This tooltip is gonna get redone a little bit.
I'm getting the normal instead of the rotation. There you go.
There we go. What else I can explain? Even there's something interesting already. If you go and change, let's say, because that's something you're gonna use in this example. Let's say you want to have the scale a bit randomized.
Yeah.
Before, you had to use the attribute randomizer.
Yeah.
Now I can just go to the...
With this thing, for example.
Yeah, I can just do Shift A and go to random. It's an input random, I believe. No, random is... I forgot what it is, so just type it. Random value.
Random value.
Now if you just connect this to the scale.
To the scale, I guess I need to be a vector, right?
You don't have to.
Ooh.
If it has a float, it's simply going to be using the same value for all of them. So if you want a uniform scale, that's what you do.
Oh,
As you
nice.
can see, you can play with the range. However, right now, if you change the amount of pebbles you're distributing, so if you change the density maximum or distance minimum, you see there's a lot of popping in and out.
Yeah.
That's because we are not using the stable ID field we have there. That's a bit of a new concept.
Stable ID, this guy.
Yeah. So if you just connect the stable ID to the random value,
to the random value, any value,
to the random value node in the ID input. Yeah. Because by default, and that's the something about fields that work the same way for shader nodes. Basically, if it has nothing connected, it has always a fallback.
Yeah.
In this case, the same we have a UV as a fallback to a lot of the vector input in shaders. In this case, basically the fallback is the ID itself, the thing we see in the spreadsheet editor. But in this case, we want something else which is called a stable ID.
So each point has its own ID that I can use for anything, for coloring, for anything. It's an attribute, right? Oh, I can even mouse over and get the value. So it's stable ID anonymous attribute. Anonymous means that I didn't name it manually, right?
It means you didn't name
it's
it.
Automatic.
Yes.
Behind the scenes.
It also means it doesn't show up in the spreadsheet editor because it is not a name per se.
Okay.
So did you see how stable it is now?
Yeah, well actually I was just changing this value and it doesn't it doesn't jump anymore. If I mute this thing. Oops.
Control Alt. And it's something that even Simo was proposing, if you could find a way to have the stable ID as the default for those.
Yeah.
But has still being discussed.
Yeah, so super nice. Cool.
So we saw, but the interesting thing about fields is that, let's say you have another instance on points node connected to the same points.
Let me move the entire thing here. So let's say we have what? Sorry, another instance on point.
Yeah. And then you connect, maybe create a different set of points to be used.
Different set of points.
Yeah, just duplicate this node and just change its parameters to something else. It doesn't matter. Change the seed as well, just so it's more random. More random. More random.
Yeah. And I can just join this.
Oh yes. Do you have the Wrangler enabled? No.
String join. Spoiler alert, that's something new that also is incoming. I didn't have the Wrangler add-on enabled. So okay, I have the points. I need to instance. Can I instance the same queue or do you want?
Instance something else just so we can tell them apart. So the sphere.
The icosphere. Well, I have a bunch of objects I could have. Cool, there you go. And then I can make this smaller.
Yeah. But now you can also, if you connect the random value there. Okay.
The random value, this one.
Yeah. So you can even unconnect from the ID. Let's ignore the stable ID for now. Just cut it. So if you connect the random value there in the scale. Oh, okay, that's a big scale. Oh, because you need to change the radius here.
Sorry.
Yeah. So this way, that's when you start seeing fields as something different than the data flow. Because the same field is connected to both nodes. And even though they have a different number of elements, of points you're instancing, they can still work. And it knows, okay, for this geometry, I have 100 points, so I'm going to create 100 random values. Oh, for this other, I have 10 points, I'm going to create only 10 random values.
It just knows somehow.
Yeah. And that's also why you see then as represented differently in the node editor. Basically, if you see the dashed lines, those are basically callbacks. Once you get to this node, it goes all the way to the beginning, and then gonna.
Yeah, I was wondering. So this means fields, the same as as this shape.
Yes.
Yeah. Cool.
The other interesting you can do, if you add a math node between the random value and the one of the instance points, you can just multiply the math, yeah. Or you just add or multiply.
Yeah, anything basically.
Yeah. And this is going to be something that's going to be quite useful. I can show quickly, because if you get an attribute that someone painted, you can just go and treat and multiply these, operate on that, and you connect to the density to distribution factor to any of
So
those
this could
parameters.
be like a weight map.
Yes. And you
Wow.
can use these in different ways. So
It's like shading almost, right?
it's very similar to shading. The difference that shading usually has the same context inside the whole node tree. While here you might have different geometries, and one of the geometry might have a field, the other one might not have it. I think it'd be interesting to maybe try to start playing around and start to
to convert this thing.
Yeah, just to do the basic distribution. It's maybe can just remove the
second
one,
the second one, and the cube, and instead of the cube, let's use
remove the add over there as well.
GeoPebble. Sorry.
Remove the add one here.
Yes. And it's GeoPebble, so
yeah,
I can do this. Is that still legal?
So fancy,
yes.
yes.
Can drag and drop.
Connect to instance.
There you go. I have some pebbles.
If you want a similar result to what you have, you can just copy the values. So distance minimum was 0.02, I think.
The minimum distance 0.2. Yeah, let's do it perfect.
The minimum, yeah. The maximum though is the thing that's using. In this case, was multiplying the value from the modifier.
I can just bring that. Right?
You can just bring.
Ooh.
And now I need to apply the mask.
Yes.
I'll apply it as a factor.
It's a factor.
So if you just connect the factor, as you can see, that's a third shape we haven't talked yet. So we talked about the circle, we talked about the diamond.
Yeah.
This is a shape that might change. There's a design to do something that's maybe more intelligible.
What does it mean?
But that means it's an input that can receive either a field or a single attribute, single value.
So this or this.
Yeah.
This is the merge. Okay.
So as a comparison, the distance minimum is one minimum distance to the entire point distribution node.
Yeah.
Same goes for the seed. But the density factor can be different for the different parts of the geometry. So if you just connect these to the outside, to the group input,
I can expose it, you mean?
Mm-hmm.
Here?
Yeah. Give it a nice name.
Give it a nice name.
Such as large pebble map. Or map.
Map.
By default, when you expose those fields outside, it gets mapped as a single value.
Yeah.
But you can also, if you click on the icon for the spreadsheet, you just can use instead a vertex group.
Oh.
An attribute.
So I can. This was the large.
Mm-hmm.
There you go. Nice. So there is a toggle between using a single value or whatever attribute, mask, vertex, color, anything.
Yes. And something you can do that was not possible before, can just try to just add a multiply, similar to what we just did, right? Add a multiply, but in the density factor.
So I can duplicate this here.
And you can just play with the scale a little bit if you want to tweak.
Oops, here. not be.
Yeah.
Oh, so I'm multiplying the vertex group.
It's super powerful. If you want to do one-on-one with the old file, you need to remove that, but
can do color ramp?
You can do color ramp. Do we have color ramp already? Don't remember.
Yes. Yeah, I think we have color ramp. Yeah, that's pretty neat. Oh wow, that's super cool.
Super neat, yes.
Nice. Nice. And this is a function. You can see here. That's so cool.
And of course, you could use this for again for a different part of a different node that had a different resolution. Something that you don't even need to think about is what is the domain. So we basically took a mask, which was a vertex group. So it's stored in every vertex corner.
Yeah.
And we're passing to a node that is expecting the data in, you don't see here, but maybe could even make that more visible, but just expecting the data in face. That's why the name of the node is distribute point on face.
Yeah.
So it's automatically extrapolating or interpolating from face corners to the face themselves. But the same attribute could apply to another node that require edges and would just work automatically. That's one of the strengths of the field system. So maybe remove well, can leave there the color ramp, whatever. In instance, may want to randomize a little bit the rotation. How about that?
Yes.
Now let's try to do it yourself.
Myself.
Yeah.
randomize the rotation. Well, I can use the random value, right? Random value. By the way, we're on YouTube and you're making me do things by myself. Okay, so I want to randomize the rotation. And well, actually, it can just be a float, right? It will convert. It should convert. So there you go.
For rotation, what we were doing before at least was going from minus p to plus p.
Yeah.
Using 10 decimals of percent.
10 decimals. Okay.
Go try to remember.
Maybe not.
No, you don't even need to. Well, try it. You don't even need to connect the original rotation as an input.
Not even. It's just.
Just ignore it.
It just knows.
And it's gonna be random.
So... It just knows that it's a rotation attribute.
Yes, and it's
and
you're not multiplying the rotation, you're just replacing it.
Yeah.
So it's also. So I would say from minus pi to pi.
Minus pi to pi. Wow.
And remember the thing about making it stable. So once again, if you change the, well, you'd even try if you change the large pebbles in the modifier.
This.
Yes.
Oh, it jumps.
It jumps a lot.
So I want to pass this guy over here.
To the random value, at least.
To here, to the random
value.
value.
I think maybe that's all. Yep.
Oh, there you go.
That's fine. We connected the large pebbles. We didn't even look at the. Oh no, we did look at the result. We saw the color ramp.
That's so
and the original file we're doing is something similar for scale. Which
for
is
scale.
Yeah, which basically is the.
So I can just basically do this, get the same for scale, and this I can use a float.
And this can use a float, yes. And we're doing from point. I can check down there. Don't remember.
So scale is 0.25 to 50 to 600. 600. There you go. And scale.
There you go.
There you go. Super neat.
And that's pretty much the how I got the first pebble. The other ones are just a bit different. It'll be interesting. You can try to do.
But this is the same. It's a copy paste. This is the same.
The method is different. So if you maybe open the file which we already set then up.
Okay, but yeah, at a glance, is the point distribute, attribute, randomize, all three of them.
The difference is that one's using the Poisson disk, the other using the random.
Okay.
And for the random one, it's pretty nice because you can just multiply the input mask with the factor.
Yeah.
And you don't need two parameters as we had before. Because before we had the density max and the density attribute as two separate parameters.
Yeah.
But now if you go to the new, if you just duplicate this node and make
this whole thing, I guess.
I can do something else.
Well, this one I don't need. What for?
And then just to show the options now that when you change to the random points on face.
I need to get this guy here. I need to get this guy to join it. And if I need to, this is a gel pebble, it's fine.
It's gonna be a different pebble, but that's okay.
Yeah, no, it's I think it's all the same pebble, right?
No, it's the
pebble. 04. Okay, can do pebble 04. Yes, and the random size is much bigger, I think. This is
but this is fine. I'd like to if you change the method of distribution from Poisson disk to random. Now you can only have the density. You no longer have the density mask, maximum, and the attribute mask.
Yeah.
So how do we do? First, you want to be able to get the mask from outside.
Yeah, so I'm gonna
maybe start there.
Get this guy density outside, right?
And
I'm gonna name it as, what is this?
That's the median pebble mask. All right, and you change it to attribute.
And this guy there you go.
Okay. Is it working already? Probably is. We can just hide the big one. No one cares about them.
I can just basically
mute the connection.
Mute this. Yeah. That is here.
Yep.
Like if I just see this, yeah.
Yeah, no, it's totally there. The thing is,
super tiny.
For the video, it's gonna be terrible. Okay, there. That helps. The thing is, the densities was way larger before, because
Yeah.
before we are taking the number outside
Yeah.
and then multiplying. So basically, if you know what you want to do is to multiply the mask you just brought in with the factor that was exposed times 100, which is
So on this mask for
Mul-
100.
yeah. Before, one thing I recommend is to connect everything before connecting there. Otherwise, the computer might hang. It happened to me. It's terrible.
Oh, but that has to do with
With me not being wise enough to do it one step at a time. Yes, and this you want to multiply the mask by the value that's outside.
the pebbles here.
Mm-hmm.
Ooh.
So now technically, if you change the value there, you see already, but it's very tiny. The other thing we do is multiply that number by 100.
This guy by 100.
That's where we're gonna be careful because.
Okay, and this will just know. Okay, let's do 23. Well, there you go.
Yeah, it's fine. I just connected the thing 100 by 100 by was too much.
There you go.
And
That's
of course,
pretty
if you
neat.
change the scale to the what you had, then you have the
Yeah, the scale. There you go.
then you have both pebbles.
And I
Quick-
need to
quick
connect to
system.
both here, and then I need to.
We already have a file that has all the 3 pebbles converted, which is online.
Unavailable here. I just downloaded it without you knowing. There you go. So this is the thing.
Alright.
Okay, this looks more clean. I made a little bit of a mess. You use the object info instance or you're hiding stuff.
I'm
from
using Ctrl H aggressively in this file.
Control H or toggle node options, hidden sockets.
Hidden sockets.
The sockets that are not used can.
I also I also duplicated the group input a few times.
Oh. But just for readability. You
Just
don't
for
have to do this.
readability. Yeah.
That's awesome. So you mentioned that not all the nodes are converted. And I'm making like you're telling me, so where can I find it? Well, actually, there is a link that is in the description on the list of nodes that need to be imported over, right?
Yes, this covers most of the nodes.
Yeah.
The exceptions are, for instance, the texture. Before I had a texture attribute. Now, this was one of the few parts of Blender that was still using the old texture-based, node-based texture.
Yeah.
And it is to try to replace these to something similar to what you have in Eevee and Cycles, which is a dedicated. We have a dedicated cloud texture node, dedicated image texture node.
For H texture, so it will be like shading basically at some point.
Yeah, just like shading, yes.
It's just merge.
I'd
Nice.
expect at least for 3.0 for us to have the image texture node.
Wow, which is like sample, like it would be the old attribute sample texture.
Yeah, so it'll be a way to replace that for the non-built-in textures.
Okay, these are the removed nodes. Quite a lot, so much work, and these are not necessarily any change. Is there an estimated time when this is gonna be available?
There is, but videos are timeless, so keep checking master.
Keep checking master, download it, but of course 3.0 is gonna have
3.0 should have it all.
If you're using
Yes.
3.0, you're somewhere from the time in the future. Don't even bother. Okay, so people, download here the builder.blender.org, get the latest 3.0 alpha geometry nodes. This file is updated by the time of this video.
Oh, it's already updated. Is there?
Yes. Yeah, but not all of them. I'm
Not of
pointing
them.
this one.
And
Yeah. Okay. This one. So if you want to use it as a reference, but it should be pretty straightforward. And also on YouTube, people are making videos everywhere.
and if you're doing some nice art with these, use the geometry node hashtag, BT3 hashtag.
Yes.
Because for 3.0, you want to expand. We might not convert those sample files ourselves.
Yeah.
Maybe the original contributors can do that, but also looking for new sample files. There's so many nice ones already. People using fields for some mixed Doctor Strange effects and I know I'm already enamored with the results.
Awesome. Okay, well, thanks for the explanation. Thanks for tuning in. I think we are going to play with this a lot. It's a whole new world for geometry nodes and for Blender itself. So
and I'm very happy in behalf of the team and everyone that's contributing to that. It's just so nice to see people using it, giving feedback, just doing real production art, the commercials, TV ads already with geometry nodes and now trying with fields.
Yes, if this is already in master, so if something doesn't work, please report it. That's all. Thank you,
Thank
and
you, Pablo.
bye.